I think we are on. Working? Is it on? Can the internet hear me? Yes, it is. Time to get them Reddits. I'm gonna post it on Reddit. Hopefully, become an internet phenomenon. Okay. Here we go. For some reason, I'm like, I've never streamed before. I don't know how this really works. Okay, we're on. Time to continue the math and all of its glory and wonder. Okay, here. I really want to know though how to set this up right here. Because then I can see people talking to me. People can ask me questions. My classmates could ask how to do problems, things like that. Let's see. Um, this is a cool landscape. There's like hills in the background. I want something more like the Matrix. This complete blackness. So what do we want to do? We want to do integral of somebody messaged me on Facebook. Somebody done did it. Man, I have the sudden urge to poop. But there's so much math to be done. There's no time to poop. Okay. Well, seems to me we're going to do something along the lines of secant. We have a secant squared times a secant squared. And we're going to put everything in terms of tan. It's a 5. So I broke it up into this. So if we remember the identity for secant squared theta, so I can't remember right now, so I'm going to do sine squared x plus cos squared x equals 1. So to get secant, that's 1 over cos. So I divide everything by cos. So I have a cos here, cos here. That's not 2. So this is tangent squared plus 1 equals secant squared x. Okay, so let's, what's the integral of, hmm, oh, no, I see now, okay. All right, so we have a, so first I want to say u equals tan x, and the du equals secant squared x dx. Ho ho! Oh, 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 it's magic! You know. So we have a u to the fifth, 1 plus u squared, because this guy is from that, and then the du is just this guy right here. Du. Cool. So yeah, so this is our new integral is u to the fifth, 1 plus u squared du from 0 pi over 3. So now we can evaluate him. That's easily done. Do that in my sleep. So we have u to the fifth plus u to the 7 du. It's an integrating machine. So our new integral will be, walk over here. So we had what, u to the fifth? So we have u to the 6 over 6 plus u to the 8 over 8 evaluated from, that is super bright. That's way too bright. It's like blinding me in VR. 0 to pi over 3. Oh, silly me. We had to change the bounds. So we could just substitute u back in, right? But instead, I'm just going to plug in these old bounds. So tan of 0 is 0. So we still got 0 at the bottom bound, a. And then tan of pi over 3, what is that? Let's see, sine of pi over 3 is root 3 over 2, right? Root 3 over 2 divided by, so times 2. So it's root 3, right? I can't remember my cos of pi over 6 is root 3 over 2, so cos of pi over 3 is 1/2. Okay, yeah, so you have root 3 over 2 divided by 1/2, which is root 3. All right, it's root 3. So now you just plug them in. Just plug them in. So we get root 3 times root 3 to the 6 over 6 plus root 3 to the 8th over 6. So that's going to be, let's say, 3 times 3 times 3, right? Because 2, 4, 6. So we have a, excuse me, 27 over 6 plus, this is 3 times 3 times 3 times 3. So what's 27 times 3? We get 60, 81? I think it, no, that should be an 8. No, and this is our answer. If I had a calculator, I would do it more simplified, but I don't really care. Because that's not the hard part. Cool. Let's just take a snapshot so I can check my answer later. So yes. What problem was that again? It was 2E. 2E. Mm-mm-mm-mm. Mm-mm-mm-mm. Man, you know what would be really awesome if I set up my VR in such a manner where I could poop while doing calculus in VR. Now that would be awesome. Speaking of which, I'm going to take a bathroom break. Well, that's cool. You can read the print on my pillow. Home sweet home. I have the overlay. I can see it. Turn with an empty bowel. Good thing I'm wearing my kilt. What did I eat? gentlemen. I've returned from the land of the dead. So, in my old house, there was a sign that said if you had diarrhea in the last 2 weeks, you weren't allowed to use the pool there. So I'm definitely in that boat. No more pool for me. All right, let me just put on my cyber gear. We can be on our way. Okay. Here, my thing's stuck on something. Get comfy. Ted texted me. He said he's coming over. Except he said that like an hour ago. Okay. Let's move on, shall we, to the next problem. Oh, let me put in my headphones. That's the only annoying thing. Is these headphones that come with the Vive. Kind of a pain in the butt to put them on. Ugh, the strap broke. Yeah, you really have to have the Vive right in the middle of your eye as a screen, or else it kind of gets fuzzy. Okie doke. Here we go. Next problem. Reference images. Next problem. Okay, evaluate the following integrals. Oh, these don't look very hard. Let's have a nice fuchsia. Ah, yes. Oh, I have the straight edge tool. Alright, we want the integral from 1 to 9 of 1 over x minus 9 to the cubed power dx. Well, I was going to immediately try u-subbing it. Du equals dx. Okay, that's not bad. So really what I have is u to the negative 1/3 power du integral from substitute in these for x to find the new bounds. So I have negative 8 and 0. Those are kind of weird bounds. So if I integrate this guy, I'm going to add 3 over 3 to the power. So I'm going to have u 2 over 3 divided by 3 over 2 evaluated from the new bounds of negative 8 to 0. So f of b, so right off the bat we get 0 minus, so we have 0 minus negative 8 squared cube root power over 3 over 2. That's some algebra nightmare there. So we have 64. What is the cube root of 64? 4 times 4 times 4, right? 16 times 4, what is it? It's 24, carry the 2, yeah, that's 64. Nice. So we have a 4 over, so we have 8 over 2, so we have 4. So that's the answer. Boom. Let's just take a multi-cam shot. So I can, let me highlight this button. Yeah. Just take a picture. I can refer back to it later. Cool. Hey, that's cool. Documents. Wait, what is this? Trader John's? Neighbors? Oh, it's like the history of things I've been doing. Okay. I'm just gonna teleport like over there in the distance. They really need to make this infinite, like the room, so I could just teleport and way far off in the distance I could see my past work. Okay. Exported? What the hell does that mean? The fuck? The hell? What is this? Next problem. Ooh, nice, nice blue. All right, integral from 0 to pi. Oh, you just memorize this. Of secant x dx. Okay, so this equals this by memorizing 1/2 natural log of secant x plus tan x evaluated from the bounds of 0 to pi. Secant, so we have a -1 plus 0. Uh-oh, so we have a 1/2 ln of -1, which isn't good because you can't have a negative in a natural log. Minus ln of 1, which is just 0, right? So I think the answer would be like this diverges. So I guess it's just like the graph of ln looks something like goes like this, and then it hits and goes down to negative infinity. So if you have a -1, you know it's going to negative infinity. It can't be over here. It's impossible. There's an asymptote right here at the y-axis. So I'm just gonna guess negative infinity. That's what I would put on the test. Next problem. Oh, where'd my reference image go? Let's teleport over here. Oh wait, no, I want to bring this with me. Over there. Go there. Oh, there's a wall over here. Next problem is... Ooh. Infinity. One. You know, the quality of this JPEG file is pretty good. Like when you put it right up to your face. But it's super teeny tiny, not so much. You can't really make out anything, but and you just grab it with both sides and you can just, you know, pull it out. X ln of x. And this is so damn bright, like against this blank. Like, ah, nice. Just blank darkness, and then oh, oh. Hmm. Hmm. Well, we have two functions going on. Where the hell's my microphone? Why was that so loud? Jeez. I don't know where the microphone is. I think there's one installed on the Vive. Like whenever I give a big sigh, it's so loud. I'm gonna sit on my couch. I think my couch is here. Yes, sitting on my couch in VR. Hmm. Well, I guess I can just say u equals ln of x du equals, yeah, this works, dx. So if I substitute that in, uh, I'm gonna get, this is easy. So you just get 1 over x u x du integral from 1 to infinity. So this guy and this guy cancel. So I just have 1 over u. Well, that's an n, not a u. Equals 1 over u integral. But now we must change the bounds. So we have 0 because ln of 1 is 0, and ln of infinity is just infinity. So now we have this. So I have ln of u evaluated from 0 to infinity. So you're going to get infinity minus infinity, which is just infinity. So I think that's the answer. Oh, wicked. A dog is sitting on the couch. So there's an option to do like an overlay, so you kind of see like a rough outline of physical objects when you have the VR headset on, so you don't run into anything. So I see like it's like Tron vision. I just see like a blue outline of my hand and my dog and everything. Okay, well, I can just sit on my couch actually and just teleport myself. What the hell's the thing? Aha. Nothing's. The wind's blowing outside. Oh no, that one's a bitch. I don't know if I remember how to do this one. Okay. Let's see. I forgot the formulas, but we can give it a shot. 9 minus x, and then the bounds -2 is less than or equal to x, which is less than or equal to 2. And we want to. So the question is, find the area of the surface obtained by rotating the curve, that guy, from these bounds about the x-axis. X. Okay. I mean, how do I? What the hell? Wow, I can do crazy Tron vision. I'm hitting a button and it's like changing the. That's pretty cool, actually. Why can't I go? I don't know why I can't do Steam overlay. That's okay. If I remember correctly, it's something along the lines of. Let's see if I can remember the. You want to do integral from -2 to 2 f of x times square root 1 plus. I'm running out of room. So I want to put myself back a little bit. Forward a little bit. Back a little bit. Too back. Just right. Okay. I think that's how you do it, right? You just do, because we're doing the x-axis, we want dx. So we're going to dy dx squared dx. But if I'm not mistaken, there's like a 2 pi somewhere. That's like in the formula. I forget, though. I think it's something like that. So. Okay, well, what is y prime? Y prime is going to be, so we have to square it. We're going to have a x over root 9 minus x squared, right? Because you have 9 minus x squared to the 1/2. So you take the derivative, you have a 1/2 9 minus x squared, -1/2 2x. So this 2 cancels out here. So you get just an, yeah, okay. That's correct. So I have the f of x, so 9 minus x squared times 1 plus x over root 9 minus x squared to the 1/2. So this is also to the 1/2. And this is all from -2 to 2 dx. And that's the integral that I need to solve. Makes sense. Feels right. I hate these rotating cylinder problems. They are a real pain in the butt. Oh, I hear the po-po. Going to arrest some illegal Mexicans. Yeah, my bike got stolen because I live in the ghetto. So yeah, so over there, the square, so I get x squared 9 minus x squared. And I distribute that 9 minus x squared, so I have 9 minus x squared uh, plus, so that cancels out. This is all underneath the square root. Kind of nice doing lazy math, even though it's not very organized. Sitting on the couch. I need to go like do some laps in the pool. Drink some caffeine. Feeling a little tired. Yucks. Yeah. Mm. And I did something wrong there with the algebra, distributing that. Because I really should have 9 minus x squared. There's something I don't like here. Hmm. What don't I like? I don't know. I don't know. Alright. I'm getting kind of sick of this. I'm gonna take a 15-minute power nap, drink some caffeine, do some laps in the pool. I'll be back in 30.